So, good afternoon, everyone. I am Bruno Vicenzi. I'm from the European Powder Metallurgy Association. We are the coordinators for the REPTiS project, and we are happy to have you here in our webinar today, which is the second event of a series of training webinars that we are organizing during the project to train or educate a little bit on the topics of our project, sometimes related strictly to what we are actually doing, sometimes just on the topics that we are touching. So today we will have, let me share the screen. We will have two presentations after mine. I will just give you an introduction to the project. We have two lectures today from our partners from the consortium. One will be given by Nikolai Kashaev of the Helmholtz-Zentrum Hereon in Germany, and it will be about high cycle fatigue of titanium components, performance prediction, and life extension. And then after that, we will have a presentation from Artem Yarovinsky from Velta R&D Titan, and also from the consortium, and he will explain more about the Velta T process, which is the process to transform, actually title I can read, from ilmenite to low carbon titanium powders, the Velta T process. That's telling everything. We will have some Q&A at the end of each presentation. You at the moment are not able to switch on your microphone and camera, but you will be able to do it when I will switch to the Q&A setting in this platform. So you can also pose the question yourselves by opening the microphone and the camera if you want, or you can just type the questions in the chat that is here just at the bottom right of the screen. Right, so I hope you will enjoy the webinar, and without wasting too much time, because I want to leave as much time as possible to our partners for their lectures, I will start presenting something about the project and its rationale. So, yeah, is it moving? Yes. The REPTiS project is started in September 2024. It's a Horizon Europe project funded by the European Commission, and it will last 48 months with a total grant just above 7 million euro. We are, as said, as EPMA, European Powder Metallurgy Association, we are the coordinators of the project. And what is the rationale of the project is that, as you all, I think you all know, there is a list of critical raw materials that is prepared by the Commission every couple of years, I think. And titanium metal is considered a critical raw material by EU. That's also especially because of the economic importance and also because of the so-called supply risk. The supply chain for titanium is not very well secured for Europe. And this is evident if you look at the fact that, in fact, in Europe, practically everything is imported in terms of titanium. On the left, you can see the titanium production of titanium sponge in countries in 2023. Even you can see that Europe is not even on the list, apart from Ukraine that we have on the list there. And if you look at the situation after the Russian-Ukrainian war, it even got worse because, of course, the traffic from Russia has been practically blocked. Maybe not all of that, but especially from Ukraine, there were also losses in the possibility of transferring material to Europe. So the supply chain is even more disrupted. and we have to import more from countries like Japan or Saudi Arabia, or the US and China, of course. So what we have as an objective is to offer a new supply chain, and this was also something that was in the call where we applied. They wanted supply chains to be developed from strategic partner countries, so that Europe could be less dependent from, let's say, risky supply chains. So we put together this consortium where we have the partners in Ukraine, which are key, of course, for the project. But we have 13 participants from industry and academia, and we coordinate. And the rest I already told you. You can see all the participants in the map on the right. And also here in this other slide where you can see their roles. So clearly we start from the mining, and there we have our partner Velta mining in Ukraine, and they have mines where they extract ilmenite sustainably. And then this raw material can be processed also by a Velta company, Velta R&D Titan, which will be the topic of the second lecture today. This process also has byproducts, so everything, it's actually a zero waste process. And then the processing will lead to the fabrication of powders, irregular or spherical. They can also be spheroidized, that can be used in advanced manufacturing. And then we have our two main streams towards metal injection molding, which is one of the technologies that can be used, and additive manufacturing, which is the other technology we plan to use. And you see that we have industrial partners for all these steps, and also academic partners, starting from Montana University at Leoben in Austria, helping on the mining side, Technalia, Hereon and Fraunhofer, who focus on the characterization of the powders and will also characterize the components that will be produced for validation. And yes, as companies, we can list for metal injection molding two companies, one in Germany, Element 22, and one in Spain, Alpha Mintech, and for additive manufacturing, IAMG in Poland, and also GKN Aerospace is collaborating on a specific case study, and also have University West there. So actually, what we were planning is to tackle the fact that the present chain for production of titanium powders is quite long. It's based on the Crow process, which is quite energy intensive and has waste streams that are not negligible. And then it also, after the obtainment of ingots, which, as you've seen, are mostly not coming from Europe but from outside, these ingots have to be used in an atomizer to produce the powders. And normally, to produce titanium powders, you need specific technologies like the EIGA, so electro-inert gas atomization, which allows for the production of clean titanium alloy powder, which is spherical powder. But all this is quite energy dependent, and high level or carbon footprint is produced. Whereas the Velta company already had patented at lab scale a process which will be explained later better, so I will not go too much in detail now. But okay, it's a complex scheme that you can see here on the right, but basically starting from the ilmenite, it's possible to arrive to a sponge titanium form, metal form, by chemical methods. And this sponge can be crushed into irregular powder directly without passing through melting or any other high temperature process. So finally, you can have irregular powders of the alloy already that you want, because you can add the alloying elements along the process. And all these powders can also be spheroidized into form which is probably more useful for additive manufacturing, for instance. And then all the waste streams that could be waste, but they're not waste because they are actually transformed into byproducts like the iron oxides that you can see on the bottom left for pigments, or all the other examples that you see there. So there's basically no waste. Some materials are also recycled within the process itself. So it really gives a lot of advantages that you can see listed there, and finally it can also reduce the cost of the finished products or the powders, and of course other components you can produce with these powders, and the carbon footprint and other environmental indicators. And this is what we have already as a target. As you can see there, we will have to confirm, but you can see that the advantages in terms of energy use and carbon footprint should be really remarkable. We will contribute to secure a supply chain for titanium powders with a source in Ukraine, which is also a strategic objective of Europe. And all this will be sustainable, and as said, the approach is a zero waste one. We will do it by improving the Velta titanium process, scaling it up to the higher volumes that we need. And this is through the ilmenite mining, extraction, and processing. We will demonstrate this by producing real parts with the technologies that I mentioned, metal injection molding and metal additive manufacturing, and that will be used to validate the powders and create acceptance for the new powders for the market. And we will also evaluate them in terms of sustainability. We do have already some improvements that have been done in the mining and extraction. So the weathering crust material has been studied, and it's been confirmed to be valuable for the extraction of titanium. The mine was improved by a better transport scheme that allows to not waste water and electricity, and also the pumps will last longer. The separation of the titanium has been improved by adding mechanical scrubbing, or improving the mechanical scrubbing and adding a better magnetic separation. And then there is an additional kaolin plant that will also improve sustainability by exploiting part of what is inside the mineral. And also Velta has also looked at solutions to have a better energy mix by using solar or multi-fuel for drying the drying ovens, or using liquid propane gas autonomously. So here are some images of what has been happening. You can see on the right some processing of the kaolin, and what has been done, the wells that have been done to study the material, and what is the actual flow of the process there. Then the concentrate has already been given to Velta R&D Titan, and some batches have already been prepared. And you can see some samples already prepared there by using these powders. So I think we are progressing quite well. And finally, we will produce parts for the medical, aerospace, and consumer goods for the validation. I'm coming towards the end. As I said, we will also do the sustainability studies to make sure that what we've done is done in an efficient way. And last thing I would like to mention is that we are also organizing a nice event in October, together with the EPMA Congress in Budapest, the Euro PM 2026. There will be this workshop on the whole supply chain of titanium. which is co-organized with two other projects, Horizon Europe projects that share with us the topic of titanium, Eurotitan and Avantis. It will be free, but people will have to register to access. So if you happen to come to Budapest, or if you want to plan to come to Budapest, you have a good reason to come in October for our workshop, titanium workshop there. And if you go to our website, you will see some more information, and you can also use the QR code to register directly. So this is it. I would like to remind you that you can follow us in our social media and website to keep track of our news. And well, I'm ready to answer your questions if you have any. Otherwise, I will pass leave the floor to our lecturers that will tell you more technical things in the next hour or so. Thank you. If you have any question, I don't see anything typed, but if you want to, I can open the discussion for a moment. So if anyone wants to speak, you just need to click on your microphone and open the microphone and pose a question. I don't see anyone. Okay, there is time also later. So if there's one. Okay, maybe.
Sorry, that was a misclick. I'm sorry.
Okay.
Because I thought the microphone was on suddenly and I had to click it. I'm sorry about that.
No, it's you're excused. But it works. So if anyone wants to pose a question, that's a way to do it. Click on the microphone and you appear.